Hi everyone, and welcome back to our Kart Racer series. Over the next few episodes, we'll be going over how the AI in a racer will work. So let's jump in and get started with setting up the AI. So for the AI, they're going to be using the same cars as we are. The difference being is that they are going to be propelled manually, automatically, sorry. And then we're going to go, so I'm just going to drag in the cart here, just put this in here. Around a bit. Okay, so to get this cart to run the way we want it to, we have to go and edit how this is going to work. So currently, if I go to the event graph, the acceleration is being handled with this enhanced input. Now, if this thing is going to be AI controlled, we can't rely on this to set up the acceleration. So let's talk about how that would actually work. So this would be basically accelerating on a tick, essentially, because that's what this is doing. Triggered is a tick. So we're going to look for our tick event. It is. And I want to accelerate the AI controlled stuff. So for this, what I'm going to do is I'm just going to separate this out a little bit into a sequence. And then on here, we're going to have a thing in here for AI accelerate part. And all this is going to do is basically the same thing that as our accelerate function is doing. Okay, so we're going to take this, copy that, and put that in our AI accelerate cart. So the acceleration input for this, sorry, is going to be coming from here as well. So if I go over here, we're seeing we're using the action value from our accelerate, which is going between 0 and 1, to indicate how much of an input should we apply to acceleration input. So likewise, on acceleration, we're going to go across and put that there. And we'll correspond throttle. So that's the input setup. And because that is set up in there, that should automatically go around. But I only want this to happen if this is AI controlled. So we're going to say get controller. And we'll make sure this is not equal to the player controller. And we'll put in our accelerate cart. And for now, we're just going to put in 1. So if I push simulate, he should just go. It won't turn, but off he goes. Great. Cool. Right, so that's the acceleration part done. The next bit is the steering, which is probably the harder part. The steering is going to be using the spline to help navigate its way around the track. So it knows which way to steer, because at the moment steering is handled automatically via the torque over here. But similarly, we're going to make another function called AI underscore steer cart. And very similarly, we're going to be taking over these values and put them into the AI steer cart. And the value that we've got going into this is coming from the action value, which is going into our multiplier and into the f_interp_2. So let's go ahead and do that. And bring that into the f_interp_2. And now let's go back to the tick event and put in our AI steer cart. Now, this value that's coming into here is going to vary. This is a delta, meaning which way we move the mouse, either left or right. It's going to change this when we do it by a mouse. But for the car going around on its own, it needs to look at the track. Okay, so we've got the track spline. We know what that is. So we're going to get the track. And I want to get the steer value from the track. And so I want to get, first of all, the location closest to the track spline. So location closest. Oh, actually, no, we'll do direction closest. So direction closest to world location. The world location is going to be get actor location. And we're going to choose that as the world coordinate. So we know which way it wants to go. We want to know which way it's currently going. So we're going to do get actor forward vector. And I want to get the difference between these two directions. And what we're going to do with that is just do a dot product. So if the line starts turning, its value is going to deviate away from 1, which is straightforward. So if we dot product two vectors together, if they're facing the same direction, they will equal 1. If they face opposite direction, it'll be -1. We want to rotate this around so it's not exactly just forwards with just 1. Okay, we want that value to be basically the opposite way. So we're going to do a right vector on this forward vector here instead. And we'll put that in there like that. And we've got the right vector, and now this value should give us a positive and negative value, whether it's going to the right or to the left of the line. And then we're going to multiply it by a strength, and we'll start with 5. I need to do more than that. I'll put that in there. Let's see how that looks now. It's doing a little bit, but we need to do a lot more than that. Let's increase that strength. But its strength actually may be tied a lot closer to the acceleration. So if I get the acceleration, I'll put that in there. Let's see how that behaves with that. Pretty good for the most part. So it's going to struggle with the tighter turns, but we'll come to that in a second. No, overall, not too bad. Get stuck on that lip there, but that's fine. We actually need to get rid of that lip. I don't want that lip there. And so if I put a few of these in, we should see them all running around. And the critics can hit the speed boosters. They'll do the same thing as it does for a player character. So I might want to boost the turning a little bit more. Let's try boosting that a tiny bit more. So I'm going to go to multiply and just give it a value of, let's say, 2. Let's double it. And obviously we have to turn it so they don't trigger the lap thing, only you do. But let's keep track of that. They're really struggling with that corner, aren't they? That's fine. We'll come to that in the next part. So the next part, what we're going to do is we're going to make it try to stick to the racing line, which is the track line going across. At the moment, it's just steering based upon which way the line's going according to it. But I mean, what I could do is probably make that more central. This line, it turns a bit tighter actually. Let's have a crack at that. But what we will do is make it so that if the speed goes down, we're going to just turn the car. Let's just get in a bit more central to the line there. And let's see how that behaves with that line there. Okay, so what we'll do is we're going to make this part exponential. So to make this dot exponential, we're going to just power it by 2. Maybe take out this 2 here. We'll do that. So meaning that as the value gets larger, this will exponentially get larger. Too large. Too large. Oh, it's probably because it's negative. Hang on. We want to dot product that. We'll do. I'll tell you what we'll do. We'll put that in the center there, and then we'll absolute this. And that'll be a multiplier, basically. Yeah. Okay. Let's see how that looks there. Not too bad. Could be better. Maybe make it more exponential. Yeah, we'll make it a bit more high exponent. So we'll do that as an exponent of maybe 4. You just keep tweaking this until you get working the way you want it to for your own game. As you've discovered in previous parts, you probably want to keep adjusting this ever so slightly, fit the physics of what you're doing. Hello, what are you doing? With what you're doing here. So another thing that will affect the base of this, if I bring it back down to 2, is if I add 1 to this. So you're dealing with like larger numbers. Tighter down that corner. It's looking a bit tighter around that corner. Still need to be tighter though. Let's bring that even more in. We're gonna add that by. We're gonna add 5 to it. Let's go extreme with this. Oh, too extreme. Let's go to. So another thing we could also do is, rather than getting the location closest to it, yeah, it's having trouble with that. The location closest to it is to look at the location of roughly a point ahead, so it starts turning preemptively. So let's add that in here. So rather than getting find direction closer to actual location here, I'm going to get this actual location, add to it forward vector, forward vector, and multiply that by float. And this would be how far ahead is it going to look. So let's say 400. Actually, let's do it up a bit more, 500. And we add that onto there. So we're going to look slightly ahead of the character, work out which way it should be going. Those turning circles are too high. Let's bring that down to just 1. Yeah, the reason why you see it doing that spiral thing is basically it wants to turn too much. That's looking a lot better. Oh yes, much, much better. Oh, he's acceleration there. Okay, well that'll do for the first round of this. In the next round of this, we're going to improve their AI slightly better, so you don't do this sort of thing. If they get turned around, we want them just to go back the right way, or figure out how to reverse at least, and then we'll go from there. Hello, he's got stuck. There you go. And bring him back down. Okay, there you go. That's the start of creating AI. As I say, it works very similar to the player character. It's just that you have to make it so it does it automatically from the get-go. And we are looking at the track to help navigate which way you want to go. So make sure you get your track line as close to the center of the track as possible to make your life a little bit easier. Okay, there's a very basic setup. There are many ways you could do. So you can also do like things like machine learning if you like. But by all means, try out a few examples. There are loads of people online doing other things like this. But have a crack at this, see how you find this, and experiment, tweak the numbers, see how it works for your game. If you want to see the next part, we'll continue doing more AI stuff for our carts. You can head over to patreon.com/Ryan Laley, where a donation of $1 gets you access to all our videos early, plus it supports the channel. So massive thank you to everyone over there on Patreon who are supporting the channel right there. Thank you for watching. Make sure to subscribe, and I'll see you all next time. Bye, everyone.